Hi students, welcome back. Today we are going to look at the permutations problem on LeetCode. So this will follow the similar style to the combinations problem we have just seen. It will involve recursion and backtracking. So look at the problem statement first. Problem statement says we are given an array of numbers, okay, which are distinct integers. So there are no duplicates. We have to return all possible permutations so given a list of numbers, unique numbers, we have to return the all possible permutations. And we can return answer in any order. Okay. So let's look at an example. So if the given example is 1, 2, 3, what are the possible permutations? 1, 2, 3, 1, 3, 2. So different ways where you can find a different set. That's all. So if you fix 1, then it can be 2 3 or 2 3 3 2. If you fix 2, it can be 1 3 or 3 1. If you fix 3, it can be 1 2 or 2 1. Okay. Similarly, if it is smaller thing like 0 1, then there are only two ways, 0 1 and 1 0. No other permutation is possible. Okay. So permutation is nothing but different ways you are representing these numbers, different representations of it. Okay, so if it's just 1, then there is no other way to represent this. So it is just 1. So first, let's look at how we can solve this with an example and then we will get to code. Okay, so let's say we will take example 1, 2, 3. Okay, 1, 2, and 3. Okay, so if given number is 1, 2, 3, okay, initially we don't have anything to begin with. So initially our set is empty. Okay. Now we can pick any of the three numbers. We can either pick 1, 2 or 3. Okay. Once we pick 1, okay. So our set will have 1 and now we will have two more choices possible, 2 and 3. Okay. Similarly, in this case, our selected set will have 2 and we'll have two more choices possible, 1 and 3. Here it will be 3 and we have two choices, 1 and 2. So here if we select 2, then our selected set would be 2 and we have only one choice left now, which is 3. Similarly, here it will be 1, 3 and we are left with the choice 2 and so on. So now here, since there is only one choice here, it will be 1, 2, 3. And after this, there are no choices left. You already have all the numbers. So you don't have anything to do. This is one of the permutation. Similarly, here it would be 1, 3, 2. Okay. Like that, in every of these possible things, you will get a different number. Here you will get 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So you'll get all the permutations here. Okay. So if you closely observe, what you are doing at every step is you are deciding whether to select a number or not. Okay. So to represent this programmatically, let's take a Boolean array. So let's assume initially nothing is selected. So we have 1, 2, 3. So we have three positions, 0, 1, and 2. So each of this represent whether that number is selected or not. So initially nothing is selected. Now when 1 is selected, this becomes true. Okay. When 2 is selected, this becomes true. When 3 is selected, this becomes true. Okay. This is 1, 2, 3. Okay. Now in the next step, we can only select 2 is already selected. So we can only pick whatever is false, which is either 2 or 3. Okay. We can pick 2 or 3. Now if 2 is selected, this becomes true, true, false. This becomes okay. Again, in the next step, following similar logic, you can only pick whatever is false. So you can only pick 3 in this case and it becomes true. You can pick 2 in this case and it becomes true. So what is the combination here? The combination is 1, 2 and 3. Okay. So 1, 2, 3 is one combination. Similarly, 1, 3, 2 is the other combination which resulted in this thing. Now, if we follow similar style here, we will, so here we can select 1 or 3. So if you select 1, this becomes true, true, false. Why can we select 1 and 3 here? Because only they are false here. Okay. Here, if we can select, if we select 3, this becomes false, true, true. Okay. Now, there is only one possibility here, only one false. So you will select that. Here also there is only one possibility. You will select that. So this gives us the other combinations, which is 2, 1, 3 and 2, 3, 1. Okay. 2, 1, 3, 2, 3, 1. Similarly, if we follow this tree, we will get 3, 1, 2 and 3, 2, 1. So this is how we are going to solve this. Okay. At every step, we will pick or select one of them and we will represent them via a Boolean array. Okay. So when you say it is selected, it means you mark it as true. Okay. And you proceed. So since this is a recursion and you are making a choice, you also have to backtrack your choice. For example, you have went down like this in the recursion tree. Now to go back up and continue this part of the tree, you have to undo your choices also. So we have to recursively go down, make the choice, figure out the outputs, and again backtrack and come back. So that's how we are going to solve this. Let's look at the example code. Okay. So first we have to return a we have to create a result in a list of lists. So let's create that first. Okay. It's just a simple list. Nothing special about it. It's just something where we will store our result. Okay. Then we will calculate permute and we will store result in that. Okay. Now, if you remember, we also said we we need a Boolean array to store the flags of the things which we have selected based on how we have seen it. So let's create that also as a send that also as a parameter. And like we have seen in the combinations problem, once you have reached the end of the tree, you have to figure out the path, which means you have to select your permutation, which means you have to store your permutation. Okay, so we need one list to store that. And finally, once all of this is done, we will return the result. So how do we implement this method? What we have is integer array nums, which is our input, and a result which holds the final result, then a Boolean array which says at this point what are the selected items, and then we have uh, a list which is carrying the permutation. Okay, so these are the different inputs we have for our function. So the number, okay, a result, and a Boolean array representing what is selected and what can we select as children. This will basically help us decide what are the children, recursive children that are possible. Okay. And a permutation which holds the current combination, the path which led us here. Okay. Now, what is our break condition of this recursion? When will we stop this? We'll stop this when we have found a good combination. Okay. which means when we have in the path we have selected everything. That means the permutation 1, 2, 3 should be equal to size of the input. That's when we will stop. So our permutation is carrying that. So when is carrying the path. So when permutation dot size is equal to nums dot length, that means we have reached the end of the tree. Okay. In this case, we have to add the current permutation to the result. Okay. And we have to add a copy of the permutation because we are only creating the permutation once and we are reusing it. So if you don't create a copy, this list is passed by reference and you will not see anything because it gets modified later. Which is why you have to create a copy of it by doing new linked list. Okay. So this handles our base condition. This is where we will exit the recursion. So once we traversed a path of size equal to nums dot length, that means we reached the leaf of the tree. We found one permutation and we add that to the result. Okay. Now, what do we do for other things? How do we figure out the children and how do we traverse them? Okay. So, children are nothing but all the numbers in the given number list which are not selected. So, what we were saying was we will only pick anything which is false. Okay. Here we pick 2 and 3 because the positions 2 and 3 are false. Okay, that means whatever is not selected is a probable choice. So if the current position is not selected, okay, then we will make that choice. Making that choice is nothing but marking selected as true and adding this number to the permutation because we need the exact numbers later. Okay. Okay, so we made the choice of picking a for a child who was not picked before. And how do we know it was not picked before? Because in the Boolean selected array, it is false. Once we made the choice, now we will pass this new thing to the recursively so that we can process its children as well. Okay. How do we call it? We pass the same parameters. So since we selected this, now it will follow its children. Okay. Once we processed all its children, we have to backtrack and move back to the its parent. How do we backtrack it? In the permutation, we have to remove whatever we just added. Okay. And we have to undo our selection. We have to do this because we have to go back in the tree and process the parents as well. For example, we were here. If you have to go back here, that means you have to undo the flag you have set for 3. Okay. And you went back here means your permutation also will not have this 3. You have to remove that 3 as well. Okay. That's what we are doing here. So this backtracking is very important step. Okay. So that's all we have. So what we are doing is we are maintaining a selected Boolean array which basically holds at every step what are the uh, numbers which were already selected to reach this point, and the exact numbers that were selected will be available in this permutation. Okay, so we can also compute the numbers that were selected using selected array and nums, but to figure out our base condition that would make it a bit difficult, which is why I've taken this additional list. Okay, as let's run this and see. Okay, let's submit this. Okay, yeah. So the first step is figuring out how to make the choice and how to figure out what are the children's valid further down, and that we did by this selected array. Okay, so here we made the choice of picking a number. Here we recursively traversed its children, and here we undid the choice so that we can go back to our parent and continue the same thing for our parent. Okay, this is a simple logic. That's all we have for this video. Thanks for joining.